Thank you for the introduction. It's a great pleasure to be here to talk to you. My name is Xiaopeng Song. I'm a remote sensing scientist and a geographer. So what I'm going to show you is a lot of satellite images and the maps derived from satellite data. Most of the examples are about the US agriculture. But I'm also going to show some examples, recent research about the international, to give you some international context. As I said, I really like to go on Google Earth and find a satellite image and work on the satellite image. I'd like to start off by showing a satellite image of Omaha. This is what the city looked like just last week. And we can see, the landscape is in gray and white color, right? Some of the grounds were covered by snow. This is the image this summer in June, in July, and you can see the landscape is much greener. This is what you would get if you mount your iPhone on the satellite and take a photo, right? That's literally the photo. This is the same image. This is the same image, but we are looking at infrared channel. And this is the infrared channels are the channels preferred by remote sensing scientists because we can see vegetation clearly. Now with infrared, vegetation is in red. Now we can see how many golf courses are in the city. And with the bit of training, you can tell what crop is growing in each field. I can tell you, the dark red color is very likely corn, and the orange color is very likely soybean or alfalfa, right? And so identify vegetation type and crop type with satellite data is a classical application of remote sensing. And this is what the USDA, the agency, has been doing. USDA has been using NASA's data to create crop map over the entire US for every year. How many of you know this map, cropland data layer? I see quite a few hands. Okay, so for every 30 meter, 0.09 hectare, USDA mapped the crop type. You can see in this example, this is a typical Illinois landscape. You'll see corn and soybean. Yellow is corn, green is soybean. And the other example is West Kansas. You can see wheat, sorghum, wheat in dark brown, sorghum, and alfalfa, right? And so USDA has been making this kind of map every year since 2008, national scale. So every year we have a map, and over these years we have a stack of maps. And with that stack of maps, we can track what's going on, what's the change in US crop cultivation. And so the figure on the slides shows you changes in corn cultivation, just corn. And you see two primary colors, brown color, warm color, and green, blue color. So brown color, red color shows where corn cultivation has been going down, declining. And green and blue shows where corn cultivation has been going up. So we can immediately see a hot spot where corn has been declining, and that's Illinois. And you can see the southern Nebraska and north Kansas, that's the region where corn has been expanding, right? So this is for corn. Let's move on. That's for soybean. The soybean is more a unidirection change. Soybean has been expanding across the Midwest and the Great Plains. And this is wheat. And wheat is a very different story. across the Great Plains, in the Dakotas, in Kansas, wheat has been going down. So the only hot spots that wheat has been going up is Montana, right? So these are recent, over a decade landscape change. Before, when I was preparing for this talk, I honestly didn't know how much dynamics there was but you can see the spatial heterogeneity of it, don't you? It's a great product. USDA is making this map. It's highly accurate. It's publicly available, freely available. Anyone can go online with your computer, with your phone, and visualize this data. There's only one drawback, though. There's a relatively longer latency period when, from the satellite data to when the map was produced, is produced and released. So for this year, if you want a map of 2022, you need to wait until February of next year to get this map. What we have been doing at the University of Maryland is to create an improved version of this map. We have been collecting data, field observations, ground observations all over the US. So you can see the upper left corner, and all those red colored dots, that's the location where we have collected data. So without going too much technical details, we processed petabytes of satellite data on supercomputers, applied machine learning, artificial intelligence algorithms, and created this map product showing at the bottom left corner. So that's a soybean core map of 2021. Right now, we can make the map at November, a few months earlier than the USDA official data set. Equally importantly, the map shows more spatial details at a finer spatial resolution. So for every 10 meter by 10 meter square land, we assign a crop label to it, right? So with that, you can see a lot more details in the landscape where you would see more spatial heterogeneity, like this example in northern Louisiana. So that's the US work. A very nice feature of satellite remote sensing is we have consistent data across the Earth's surface, right? So we can examine land use changes not only in the US, but also in other parts of the world. Now, that is important for a specific location from a geography perspective. It's also important for US agriculture to know the international context, right? So this is, the image shows is actually a satellite observation. That's not a cloud-free composite. You don't see cloud. That's data processing. And take that data, we mapped global cropland change and quantified global cropland change. So you see three primary colors on the map: green, red, and blue. Green shows relatively stable cropland. And you can see US and Canada, Europe, large part of Europe, India, China, are actually relatively stable cropland. Where the dynamics are, they are in the global south. So look at South America and Africa. All the red color are in there, right? So that's where the cropland expansion, cropland growth has been going on. I just want to emphasize a number. In about 20 years, we have added nearly 10% of cropland on Earth, right? So that's a big number in 20 years. If we zoom in to South America, where I have to say the soybean expansion, the growth of soybean cultivation in South America is truly remarkable. So in about 20 years, soybean area more than doubled across the continent. And you can see in the animation, we are looking at the southeast edge of Amazon as a big area, and soybean has been filling the space. Soybean monoculture has been filling the space. Brazil. Brazil was mentioned in earlier talks. Brazil actually overtook the lead in soy production. The latest data before 2019, US and Brazil were head-to-head. But after 2019-2020 market year, Brazil was way up. And in the latest year, 2022, Brazil had harvested 41 million hectares. Now, if we convert that to acres, that's about 100 million acres of soybean in Brazil. And Brazil is also catching up in corn cultivation, by the way. They are not only expanding their spatial extent, but they are also increasing their yield. So on the figure on the left shows the new soybean field. The white shows the existing soybean field back in 2001. Yellow are the new soybean field added in last decade, and red are the new soybean field in the recent decade. So you can see it's everywhere across the continent. It's really remarkable growth. And they are also increasing their yield. As I mentioned, I don't have time to go to more details, but the right-hand map shows you where their high-yielding soybean is concentrated, where their low-yield soybean is concentrated. I'm going to talk about the third part of my presentation very quickly. And that is that related to the another feature of satellite data, which is the temporal domain. We have tens of satellites from NASA and tens of satellites from other space agencies, from private industry. Hundreds of satellites are imaging the Earth all the time. So we can use that feature not only map the vegetation, but monitor the vegetation growth, vegetation condition, and monitor the disturbance to the vegetation. So I'm going to show the example which is already showed by Mary. But this is from a different project. We are working with NASA JPL. We are rolling out a global scale. This is global scale data and service, and that will quantify and map vegetation disturbance on a daily basis. So this, but I'm going to show you two US examples for now. One is the Iowa derecho. I know most of you know of this. And this is the satellite image on the left. It's a satellite image before the derecho. In this channel combination, you see the cities and settlements and bare ground are in purple color. And the soybean and corn, all the vegetation are actually in green color. So it's a different color tone. And for scale, this is Des Moines at the bottom. On the right-hand side, that's a map derived from the satellite data. So that's a quantify that can be used to quantify vegetation loss. That's vegetation cover, percentage vegetation cover. And this is before the derecho. This is right after. You can already see the image become darker, and some of the purple showed up. And this is about 2 weeks after. Now you can see the landscape is much more, it shows more purple than before, right? And on the right-hand side, you can see vegetation loss. I only highlighted some of the clusters of severe vegetation damage from the derecho. And you can visualize that. You can see that which field is impacted and how severe it is. This is another example. It's a tornado in Alabama. The National Weather Service shows you the track on the right-hand side. Same logic. The first is the image on the left is satellite image. The map on the right-hand side, that's tornado tracks. So this is before the tornado, and that's a vegetation cover on the right-hand side. This is after the tornado. You can clearly see the linear feature. That's 2 tornado tracks. Again, this is even after the tornado, the tracks are still observable. So quick summary. Satellite data review the historical land use change in the United States, recent decades, soybean and corn, and wheat trends. But the land use change is happening around the world at big scale, especially in the global south, in South America and Africa, and I think Brazil has been, if not the biggest rival of U.S. Commodities in the international market. And we are increasingly using satellite to not only map, but also monitor and quantify, and that will be super useful for disaster response. So with that, thank you for your attention.